In this video, I want to walk through a couple examples where we use loops. We're going to use loops to control an application. We're going to use loops to protect prompts. And we're going to look at a certain problem under two lights. We're going to look at a problem that is controlled by a sentinel-controlled loop, and then we are going to rework that problem where it is controlled by a counter-controlled loop. So let's just jump right in. Here's our problem description. Build an application that converts an elephant's trunk length to weight using this formula. Weight is equal to 209 times length minus 3564. Note, this formula is only valid if the length is greater than or equal to 18. So we have a conversion formula here. Keep prompting for lengths until a negative length is entered. Then display the average weight of all valid elephant weights. So we want to keep doing some work, keep prompting and calculating until a negative value is entered. So this is a loop application, right? We want to keep doing work under some condition. We do not know ahead of time how many times we need to loop. So this falls into a sentinel-controlled loop pattern. We don't know if the user will enter in a negative value right at the beginning or never enter a negative value. So this is a sentinel-controlled loop type application. So what does that pattern look like? Well, we can use a while loop to build a sentinel-controlled loop. And the while loop generic condition would look something like this. While some conditional variable is not equal to some exit condition, I want to keep looping. This is the generic sentinel-controlled loop pattern. Now our condition is the condition that we want to keep looping looks something like this. We want to keep looping as long as the length is our conditional variable, is greater than or equal to 0, while it is not a negative value. This is our loop condition. We do not know how long it's going to take for a negative length to be entered, but we want to keep doing the work while the length is greater than or equal to 0. So if we are thinking about the 4 steps to build a good loop, this would be step 2. This is building the loop condition. Now, if you can build the loop condition, then we can start filling in the other parts. So what is the first part of building a good loop? It is initializing the conditional variable. The conditional variable in this example is length. Our loop depends on the length value. So we'll fill that in a moment. So now we're building the loop condition. We have that. Inside the loop, we're going to do some work. And what is the loop? What is the work of our loop here? Well, we want to, how about we will calculate and print the elephant weight. That's one part of the work. And also, the next part of the work we want to do is we want to calculate the average of all weights entered. So I'm going to say if weight is valid, we will sum and count the weight value. This will help us calculate average. To calculate average. So there's some work we want to do in here. And then finally, step 4 to building a good loop is the update. We want to update the conditional variable. And the conditional variable here is, again, it's length. We want to get a new length. So before diving into the code of this loop, I've tried to frame out the steps we need to take. Okay, and it all depends on setting up this while loop. So while length is greater than or equal to 0. Now let's fill in the rest of the pieces. We want to prompt the user to enter in a length to get that initial length value. So let's see how we can build a protected prompt in C#. So first we're going to set up a variable to hold the length. So I will say int length. And then we will set up a variable to hold the parse value. When we are prompting for numeric values, they always come in as a string, and we have to convert them from string to number. That's a parsing operation. Well, C# has a method called tryParse that returns a Boolean value, true if the parse succeeds, false if it fails. So I'm going to create a Boolean variable called parseOK, which will hold the result of the parse. And we can check that result to see did the user enter a valid number or not. All right, so the first part of our prompt is the initial prompt. And the initial prompt is a write followed by a read, and it might look something like this. Console.write, enter an elephant, or we'll say enter a trunk length. And then we're going to read in the result. We're going to do a console.readLine. This reads in the result, but then we're going to parse it. So I'm going to say int.tryparse. The int.tryparse method takes the string value that is being read in as an input, and then it has an output parameter to where you want to store the result. So I'm going to try to parse the user input and store the result into the variable length. Now tryparse also returns a Boolean value, so I'm going to put my parse OK variable out here to save the Boolean variable that's returned. All right, so this is our initial prompt syntax. Now we have to check the parse. Check the parse. This is part of our prompting mechanism. So I'm going to build a loop that looks something like this. While parse OK is not equal to true, so this loop is testing if the parse, or while the parse fails, what do we want to do? Well, we want to reprompt. And what does our protected reprompt look like? Well, it is a write followed by a read. So I'm going to copy my initial prompt, and maybe I will change the syntax a little bit. I will say invalid value, try again. But it's just a write followed by a read, parse the value into the length, and then store the result, whether it's good or bad. And then we will keep on looping until we will keep reprompting until we get a value that parses correctly. All right, so all of this syntax is just our protection for a prompt. Now once we get past this prompt, we should have a valid length value that we can use to enter our loop. All right, so next step we're going to do the work. The work here is calculating and printing the elephant weight, and as long as it's valid, we're going to sum and count the weight because we want to calculate an average here. So really, let's only calculate and print the weight and do the summing. Let's do all of this if the weight is valid. So how can we test if the weight is a valid value? Well, up here we have the note that says this formula is valid if the length is greater than or equal to 18. So we'll do something like this. If the length that is being entered is greater than or equal to 18, then we will calculate the weight. So I'm going to create a weight variable. We'll say int weight is equal to 209 times the length minus, and I can't remember that number, 3564. So we're calculating the weight. Once we've calculated the weight, let's go ahead and output it. I'll say console.writeLine. This elephant weighs, and we'll insert the weight value, print the weight. And now we want to add this weight to our average calculation, but we need some accumulator variables to hold the sum and the count. Now I can't declare the accumulator variables inside the loop, or else they will be redeclared again and again. So somewhere above the loop, doesn't matter where, we need to initialize our accumulator variables. So I'm going to say accumulator initialization. And I'm going to create a sum, int sum, set it equal to 0, int count, set it equal to 0. I'm initializing these accumulator variables to some starting value so that I can then start incrementing from that starting value. So I'm going to say sum plus equals weight. I want to add all the weights. And plus equals is the same syntax as sum equals sum plus weight. And then we're going to count. I will say count plus equals 1, which is the same as taking my old count value equal to, I add 1 to my old count value, save it back into count. Okay, so here we are doing all the work that we wanted to do. I'll put a little else statement here that informs the user that if the length is not greater than or equal to 18, that the length is too short. So I will say console.writeLine length too short. So I think that's the work of this loop. Now the last thing we need to do is update the conditional variable. Well, updating the length, we got the initial length through a prompt, so why don't we just get the next length through a prompt? So I'm going to copy this chunk of code, both the initial prompt and checking the parse. This is both of these components make up a prompt. So we'll just dump this into our inside the loop. Now we have our reprompt. I'm going to add a new line character before this prompt text to add some spacing. And then when we're done, when we finally exit this loop, we're going to keep on prompting, keep on displaying weights, keep on adding those weights to our accumulators until the user enters a length that's less than 0. And at this point, we can display the results. So I will say console.writeLine. We'll say the average weight is, and we'll insert our weight calculation, or our average calculation, which is the sum divided by count. But I have to be careful here. Because I declared my sum and counts as integers, if I divide an int by an int, I will lose precision. So I'm going to cast one of these as a double, and then we should be good to go. So let's test this program and see how it looks. So we have loops and conditional logic inside our main application loop. But these the while parse OK loops are only protecting the prompts. All right, here we go. Enter a trunk length. Well, I'm going to enter an invalid length, and we see that we've protected against it. That's our first while loop protecting our prompt. But when we get a length value that is entered that's okay, we spit out the elephant weight, and we should be adding it behind the scenes. Enter a trunk length. I will say 7. 7 should keep us inside the loop, but we should get a message that says 7 is not greater than or equal to 18, so it should say length is too short, and it does. Now we'll enter another trunk length. I will say 72, and we get an elephant weight. And then I'm going to enter in a value -1. This should enter or exit us from the loop, and it does. And we see we get an average weight calculation, and we should be good to go. So about 6,000. If I added 11,400 to 407, we get almost 1,200. Half of that is almost 6,000. This looks like it's working. All right. So here's our first example of using loops to build a sentinel-controlled loop application. All right. Now we're going to redefine this problem. I'm going to delete all that nice work we did, and we're going to build it as a counter-controlled loop. So here's how the problem is described and changed slightly. Build an application that converts an elephant's trunk length to weight. That's the same. The formula is only valid if length is greater than or equal to 18. That's the same. But here's how we are going to lay this problem out. First, prompt the user how many links they wish to enter. After all links are entered, display the average weight of all valid elephant lengths. So here we're going to ask the user first, how many entries are you going to give us? And then once they tell us, we can build a counter-controlled loop. We know how many times we need to loop. The previous example needed a negative length to exit the loop. Here we're just flat out telling the user, tell me how many times we need to loop, and we will loop that many times. Okay? So let's see if we can set up a generic counter-controlled loop. Counter-controlled loop, I'm going to use the for loop syntax. So for some conditional variable is equal to, we're going to give it some start value, and then we are going to say while that conditional variable is less than or equal to some end value, what am I going to do? I'm going to update the conditional variable, and then we'll have a loop body attached. So a counter-controlled loop starts at some value, ends at some value, and updates by some amount. So for example, we could start, if I wanted to loop 10 times, I could start at 1, count up to 10, count by ones. Okay? So here we need to ask the user how many links they wish to enter. So they could be, so the user is kind of giving us the end value here. What do you want to count up to? If the user says they want to enter 4 links, we'll count up to 4. All right? So I can set up my generic for loop maybe to look something like this. I'm going to say for some int counter is equal to 1, we're going to start counting at 1, and I'm going to say while we're going to keep looping while that counter is less than or equal to my I'll call it elephant count value. This is the number that the user is going to give us and tell us how high are we counting up to. Do we want to count to 4, to 10, to 100? And then each time through the loop, I'm going to say counter is equal to, well, we'll say counter plus equals 1. I want to add 1 to my counter each time. So here I'm setting up the framework for my counter-controlled loop. Now before I can enter this loop, I need to prompt for elephant count. So let's go ahead and get that value. So if I'm labeling my 4 steps to a good loop, I have my step 1, initialize. I have my step 2, my loop condition. And then I have my step 4, which is my update statement. I've built 3 of the 4 steps to build a good loop. All I need to do next is the work. Do the work of the loop. And what is the work of the loop? Well, the work of the loop is if length is valid, we will calculate and display the weight, and then we will add count weight values so that we can calculate the average. So we're doing the same types of steps we were doing before. Now I don't have to do any other update inside here. Oh well, I do have to do one thing. One more thing I have to do is I have to prompt for a length. Okay, so ask the user to give me a length. As long as it's valid, I'm going to calculate and display the weight, and I'm going to do this many times. If the user says 4, we're going to try to do this 4 times. If the user says 100, we'll try to do this 100 times. Okay, so let's prompt for that first elephant count value. So prompt for elephant count. I'm going to set up elephant count as a numeric value, so I need to set up a protected prompt. And so what does that look like? I'm going to say int elephant count. That's where I want to store the numeric value. I'm going to create my parse OK Boolean variable because I have to check to make sure that the user entered a valid number value. And now I'm ready for my initial prompt. My initial prompt is a console.write. How many lengths will you enter? Followed by a read line, console.readline. And I'm going to have to parse this read line, so I'm going to use int.tryparse. The int.tryparse method takes the user input string value as its first parameter, and then I want to stick the result into the elephant count variable. So I'm going to try to parse the string value entered into this variable that I've declared. Int.tryparse returns a Boolean value that tells us whether we were successful or not. So if I want to save the result, I need to assign that returned value into my Boolean variable. So next step is I have to test the parse. So we have to test the parse. So my prompt my test syntax might look like this: while parse OK is not equal to true, or while the parse fails, what do I want to do? I want to reprompt, keep reprompting. And that will be, I'm just going to copy my initial prompt, use that as a template for my reprompt, and maybe I will just alter the wording a little bit. I will say invalid value, try again. So we have another write followed by read, try to parse the next value into elephant count, save the result, and we will keep reprompting until they give us a valid number. All right, so again, this whole chunk of code is one prompt. Now I have a valid elephant count. So I have a valid numeric value here that will control my loop. Now if they enter in a negative number here, 1, when we start our loop, 1 will not be less than or equal to the negative value, so we will just skip the results and we're done. Okay. Now let's do the work. We're going to prompt for the length. We can't calculate weights until we get the length, so we're going to build another protected prompt here. So we're going to do all of these steps, but for a length value. So I'm going to create a variable length. I already have a parse OK Boolean variable declared, so I don't need to redeclare it. I just need to do my initial prompt, which is going to look something like this: console.write, enter the length of elephant, and I'm going to use the counter variable inside my prompt. I'm going to print my counter. So this statement will say enter the length of elephant 1, enter the length of elephant 2, enter the length of elephant 3 as we are counting up. put a new line in front to give me some spacing for my first prompt. And now I'm going to read it in. So I'm going to say parse OK is equal to int.tryparse console.readline, stick the result into my length variable. So I hope you're starting to see the pattern for these protected prompts. The only thing that's really changing is the prompt text and where I put the result. After my initial prompt, I have to test the parse. So I'm going to say while, and here I'm just going to copy this syntax again, invalid value, try again, but I'm going to store the result into length here. We're prompting for lengths. Okay, so the pattern is an initial prompt and our protection. Now, after we cannot get past this while loop until we have a valid length. So what are we going to do? So once we get past here, we have a valid length. We can do the last little chunk of our work. So I'll do that below the comments. We'll say if length is valid, if length is greater than or equal to 18, then we're going to calculate the weight. Int weight is equal to 209 times the length minus, and again, I can't remember the number, 3564. So we're calculating the weight, and then we are going to display the weight, console.writeLine. This elephant weighs this much, make a little placeholder, stick in the weight, and we need to sum and count the weight. Well, I need some accumulators, and I need them outside of the loop that we are accumulating in. So I need to declare and initialize my accumulators somewhere before this for loop. So I'm going to put a little note here, accumulator setup. I'm going to create an int sum, set it equal to 0, and an int count, set it equal to 0. Now once I have accumulator variables set up and initialized, now I can add into them. I can say sum plus equals weight, which is the same as sum equals sum plus weight. We are adding all the weight values, and I'm going to count all the weight values. Count plus equals 1. Count equals count plus 1. And this is, as long as they are entering in valid lengths, I'm going to include them in my average calculations. All right, so that's the work here. Each time through the loop, we're going to do this 1 time or 10 times or 100 times. We're going to prompt for a length. As long as it's good, we're going to just calculate the weight, display the weight, and get ready to average the weight. Now when we get outside this loop, we can display the results. Console.writeLine, the average length of all elephants is, and we'll insert that average value. Again, since we're using 2 integer variables, I'm going to cast 1 as a double sum divided by count, just so we can keep our precision. Okay, let's test it out here. Now all our prompts are protected, so when we say how many lengths, if I enter bad values, we're protected. I'm going to say let's enter 4 elephant weights or lengths. All right, length of elephant 1, again this prompt is protected. I'm going to enter in a value less than 18, and it should say, well, we didn't. Let's modify this very quickly. So if the length is greater than or equal to 18, do the work. Else, let's put a little error message that just tells the user that the length is too short. Console.writeLine, length is too short. Then we can give them some feedback on why we might not include it in the final calculation. All right, so length is protected. I enter value 4, that length is too short. Let's see what is the length of elephant trunk 2. We'll enter in a valid value, calculates the weight. Now we're on to the third one. I'll add another value, we got it. I'll enter in another value, we got it. And now after we entered 4, the user is not entering in a negative value to end the loop. We told the user how many times we want to loop, so we prompted that many times. And when we're done, we calculate the average length of all elephants. So we've summed these 3 values divided by 3. We should be good to go. Now one last thing I will mention here is that sometimes when you're setting up average calculations, what happens if the user says, I want to enter in 0 lengths? Here it's telling me the average length of elephants is not a number. So we have to, when you're building loops to control your application, there's always the chance that you never enter the loop, depending how you set it up, right? And so if I initialize my count variable to 0 and I never add anything to it, my final statement here is trying to calculate a sum divided by count. I'm dividing by 0. That's not correct. So what I can do is I can add some protection around this average, and we could do this for both of our problems. I can say, well, if the count is greater than equal to, we'll say if the count is greater than 0, this means we counted at least one elephant. So here's a little bit of protection, conditional logic we can use to protect our output. So if we've counted at least one elephant, then display the average. Otherwise, maybe we will tell the user no elephants entered. Console.writeLine will say no valid elephant lengths entered. And now we can test this out. And if the user enters in -1, no valid elephant lengths entered. All right. So here's an example of setting up a counter-controlled loop-driven application. I hope this helps kind of see how loops can be used and how we can set them up. All right.